The lesson outcome for this video is I can graph quadratics using factoring and a table. What we're going to do here is we're going to combine what we've been doing for the last couple lessons, and we are going to use factoring of this quadratic to find a couple of x values, and then I'm going to give you a couple other, or in this case 4 other x values, and we're going to find the corresponding y values, and we are going to graph this. So what we've been using recently is the zero product property. After we factor this, we say if it's equal to 0, then we can use the zero product property. Well, right now we have a y here that makes this a quadratic function. Now what we want to do here is we actually want to make this a 0. Now if we want to make that a 0, can we just substitute a 0 in for y? Well, sure, we actually can, because just like we usually put a number in for x and find the corresponding y value, we can also put a variable or a value in for the other variable for y in order to find our x value. So that's what I did here. I said, all right, let's find out when y is 0, let's solve for x. So we have x squared plus 6x plus 8 equals 0. Now we're going to use factoring and the zero product property. So since a is 1 right here, this is one of those easier ones where we can just put our parentheses down, find the factors. I'm going to keep this equal 0 here. So that means we need to take that value, that is 8. You're going to take that 8, put it off to the side, the c value right here, and list all of its factors. Well, 8 is 1 times 8 and 2 times 4. So which factor pair adds up to our middle term of 6? Well, 2 and 4. So 2 and 4 are the factors we need in our parentheses, so x plus 2 and x plus 4. Now, since these two factors are being multiplied together and it equals 0, we can use the zero product property that says in order for them to multiply together to get 0, one of them has to be equal to 0. So x plus 2 equals 0, and x plus 4 equals 0. Now we're going to solve this. So subtract 2 from both sides of the equal sign. Those will cancel. We'll have x equals negative 2. And then over here we're going to subtract 4 from both sides of the equal sign. And we're going to cancel those out and say x equals negative 4. Now notice, when we put in a y value of 0, we actually were able to find 2 different x values. The first one we'll go ahead and put right here, negative 2. X is negative 2 and y is 0. But then we have to put another one in, negative 4. X is negative 4 when y is 0 as well. Again, both of our values here go in for x when y is 0. Now we're going to just use this table and complete it the same way as we've been doing to graph parabolas. So go ahead and pause the video and fill in these 4 values here, and then we will take a look at our graph. Alright, so the values you should have got: when x is negative 1, y is 3. When x is negative 6, y is 8. When x is 0, y is 8. And when x is negative 3, y is negative 1. Alright, so the first thing I want to do is I want to talk about what happens with these first 2 points right here. Let's plot those. Negative 2, 0 is right here. Negative 2 for the x value and 0 for the y value. And negative 4, 0 is right here. Again, negative 4 for the x value and a y value of 0. Those 2 points have a special name. Those are called x-intercepts. And we've used that phrase in other areas of algebra, especially when we graphed linear equations that were in standard form. We use the x and the y-intercepts. So the x-intercepts are where the graph crosses the x-axis, and that occurs here and here for our parabola. So the next question is, well, does our parabola open up like this? Or does our parabola open down like this? Or does it open wider like this? So how does our U-shaped graph intersect these 2 x-intercepts? Well, these other 4 points are going to help us find that out. So let's plot our other 4 points. Negative 1, 3. So negative 1 on the x-axis and 3 on the y-axis. Negative 6 on the x-axis and 8 on the y-axis. 0 on the x-axis, 8 on the y-axis, and lastly, -3 on the x-axis and -1 on the y. So once again, we can kind of see the shape of the parabola formed by these points that we have in our table, and that parabola will look something like that. Okay, let's try another example. All right, again, remember that the first thing we're going to do is we're going to use factoring and the zero product property, and since we are going to have a couple of x-intercepts, we're going to put the zeros in here for y. So we want to plug a 0 in for y, and we want to find out what x equals. I'm going to ask that you go ahead, pause this video, factor this, use the zero product property, and then fill in your x values in the table. Then plug in your x values that are listed here, 1, 0, and 3, find their corresponding y values, fill those in, and then plot the points. So go ahead, pause the video, try this one on your own, and then check back to see how you did. Okay, so we should have a -8 for our c value. 8 is 1 times 8, but one of them needs to be negative, or 2 times 4, and one of them needs to be negative. If we add our factor pairs, this gives us 7. That doesn't match this. If we add these, we get 2. It matches, but we need the negative. So switch the spot of the negative, and now these will add up to -2 as we needed. So we use our factors of x plus 2 and x minus 4. And we use the zero product property, so x plus 2 equals 0, or x minus 4 equals 0. We solve these. You should have done this on your own already, I hope. And we get -2 and +4 for our two x-intercepts. When the y value is 0, these are our x-intercepts. And if we graph those, you would notice that. So -2 zeros right here, and 4, 0 is right here. Now, hopefully you also wrote down your values for y when you knew your x values. When x is 1, y is -9. When x is 0, y is -8. And when x is 3, y is -5. So we'll plot those points as well. 1, -9. 1, -9 is right here. 0, -8 is right here. And 3, 1, 2, 3, -5 is right here. Again, we can see our parabola as so. Missed that vertex a little bit. We should always try to get all the way through the points. It's a little tricky on the iPad. And there's your parabola. All right, we'll try more practice like this in class.